I'm looking good. I need the slides. From here. No, I want the slides on the screen. Okay. All right. So how is everyone doing? Good? Good? All right. Had some breakfast? When did you guys wake up? So what? 4:30. The sleeping batch. You guys really woke up at 4:30? Okay. How's the physiotherapist team doing? Did you get the gloves then? All right. Okay, cool. All right. Okay, so today we're going to be talking about prosthetics. We'll take a couple of classes, maybe a couple of hours. We'll see how that goes. And then we'll talk about neuroprosthetics. Okay? Um, let's also give it up for this gentleman who is doing this standing video recording of it. Thank you. I wish we had an exoskeleton for him so we could assist, right? So he can stand and not sprain. All right. Okay. So I'm going to start with a question. What is a prosthetic or a prosthesis? Use it synonymously. So, what is a prosthetic? What is a prosthesis? If you know the answer, or if you want to answer, raise your hand, and I'll ask you to. Yeah, yeah. Right. Very good. An artificial body part trying to stimulate a body part, right? And I don't remember your name, but you've done hand prosthetics for your undergraduate project. Very good. Yeah. It's very impressive. Some 3D printed parts and you put together a prosthetic. Very good. Yeah. All right. So prosthesis is an addition or an attachment, right? Right. And it is an artificial addition or an attachment. Yeah. Um, when do you think the first prosthesis or prosthetic came about? The first. The first. When would that be? When would that have been? Any guesses? When do you think the first prosthesis, the first? 1960. 1960. Anybody else? 1700. 1700, 1960. We got two answers. 19th century. 19th century. Okay. 19th century, 16th century. Any other answers? Anybody wants to take a risky guess? Huh? Around 40s, like 1940s. 1940s. Okay. All right. So if you start looking at these artificial limbs, they've been there from biblical times. They've been there from biblical times. 2000 years old, you will find prostheses. Okay. So passive prostheses, we were talking about. It's a gentleman from DRDO. Huh? He didn't come. Okay, okay. Oh, okay, okay. They actually made prostheses recently as well, so that's why I was referring. And some of these are from 300 BC. Some of these are from 1400s and 1800s. Even in India, we have prostheses dating back to very, very, very old, 2000 years old. We've always had prostheses, right? If you break a leg, what will you do? Put a stick. That's a prosthesis, right? Right? You might carve it nicely, shape it nicely, make it look like more human-like, etc. But that's what it is, right? All right. So so they've always been there, okay? And to present day, okay, if you look at artificial limbs, um, have you seen any artificial limbs in any movies? Yeah? Yeah? Where have you seen? Huh? Avengers, okay. Prosthetic hand in Avengers. Any other movies? Huh? Pirates of the Caribbean, he has a hook. Yeah, yeah. Very good. Okay. Yeah. Any other? Any other? Huh? Treasure Island, there's a process. Okay, I haven't seen that movie. Okay. Hmm. I mean, everybody's naming Hollywood movies. What about Indian movies? Huh? Tare Zameen Par had a prosthesis? He just had it, or was it like a show-off design type? That's what I'm asking. Oh, just they had it. Okay, okay. What about humanoid robots? Have you seen that in any of movies? Yeah, yeah, yeah. It's so quick. That's like shooting an arrow, huh? Huh? Right. Ravan, yeah, yeah. What else? Huh? फिर से you went back to Hollywood again. Huh? So this group is really, really active in answering all the movie questions. Very intelligent, very hardworking. Okay. How many of you seen this Malayalam movie, Android Kunjapan? Yeah? Yeah? Very good. Yeah, that also had a humanoid robot. Yeah. Okay. So I'm going to take you back in time a little bit. How many of you have seen Star Wars? Star Wars. So this is all the old guys are sitting on that. Okay. Star Wars. Yeah. So Luke Skywalker. Yeah. So that is there. And oh, I think I spilled the answer. Um, T2. What does that stand for? T2. What is it? Yeah, yeah, yeah. Okay, so we are same generation. Yeah. So okay, so T2 is Terminator 2. Yeah. So even there we have seen these artificial hands. So if you go back, so Terminator 2 is what, around 2000s? Terminator 2. Very accurate. Very accurate. Yeah. So somebody close the door, please. That's really distracting. Um, so I'm just making sure nobody runs away from the class. Okay. So if you go back 20, 25 years, you feel that this is all science fiction, right? But if you look at the dexterity of the limbs, it's very, very real. Okay. So that is Dean Kamen's Deca arm. Okay. Now somebody gets the cost of this limb. How much do you think it is? Quick, quick, quick. Let's do it. How much? Sir, you're saying something. $2,000. Yeah. So that was other limb. That's not this. Okay. So this is Dean Kamen's Deca arm. Dean Kamen, look him up. Dean Kamen. Okay. So this guy, he invented Segway. It was a flop, but it was a cool device. I don't know how many of you know Segway. It is like a standing scooter. Okay. Single wheel standing scooter. It's called Segway. Well, it ran for some time, but it was a flop. But he also came up with this Deca arm. We worked with this. We used brain signals to control this arm. This costs 250K per year. 250K US dollars per year. Okay, this is ridiculous. Who will buy such things, right? So, but anyway, but if you look at the form factor, functionality, these are all, you saw them in the movies, but these are all very, very real. Okay. Some patients can use it today. Okay. So artificial limbs, they are specific to the site of amputation, and they range from simple wood and metal livers to sophisticated limbs that we saw just now, right? And even in that picture, that is, I think, from eye limb. And the construction involves muscle and bone mechanics. And when you are building such a prosthetic, okay, when you're building such a prosthetic, I want you to think about what are some of the challenges you will be facing when you want to integrate such prosthetics into someone's activities of daily living, someone's life, right? What are some of the challenges you think you will face? Okay, it was on the slide and I switched back because I know you're all very active in the morning and you'll read everything from the slides, right? Okay. So can some of you guess what are some of the challenges? If you have to give such a prosthetic to somebody, what are some of the challenges they might face? Weight, yeah, okay. Weight balancing, okay, okay. So you don't want to put 100 kgs, so you came up with this fancy prosthetic 100 kgs, you don't want to put it on somebody's shoulder, right? Huh? What type of compatibility? So the place where it attaches to the site of amputation, that is also really important. So that compatibility is important, yes? Right, right. Very good. Yeah. So are they near natural movements, right? Is it easy to control? Is it easy to control? Are they near natural movements? Yes. Anything else? Huh? Oh, very, very good. Very good. Yeah. Okay. So they should think that it is their own, right? As an extension, like cell phone is an extension of your body now, right? Cell phone is an extension of yourself. Like that, they should think that this limb is their own, right? Very good. Yes. Yeah. Yeah. The action should be right. Oh, yes, 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 yes. Yeah. So the action should be real time, right? Not that you want to move and then it will move after 2, 3 minutes, right? It's such a disconnect, right? Sense of agency is created when there is less reaction time. And that sense of agency is connected to emotional connect as well, to the limb that you want to call it your own, right? Very, very good points. Yes. So everybody's alert in the morning. Yeah. Okay. All right. Anything else? Thank you. I was looking for that answer, right? So you can't make something that will cost $250,000 per year and you expect somebody in Trichy to buy that, right? Right? Yeah. Even in the US, it is ridiculously expensive. No insurance company will pay 250K per year to own a limb, right? Okay. You had your hand up? Okay. Any other answers? Yes, yes. Okay. So wear and tear, a scar. Yes. Yeah. Okay. Hope we don't get flooded. Yeah. Okay. Yeah. So a lot of challenges, right? There's something else I thought of. The one is cost. Yeah. Yeah. Biocompatibility. That's one of the first things that you read the slide or you came up with it? Very good answer. Yes. Biocompatibility. You're also talking about the site of amputation and plugging it. Yes. Yes. Anything else? See, if you answer all the answers like this, then I don't have to talk much. So this is good. Yeah. This is good interaction. Yeah. Yeah. Huh? Electrical safety. You don't want to shock somebody. You don't want to zap somebody. Right. Yes. Yeah. Safety is, yeah. Customer-based user design. Very, very, very good. Very good. Yeah. End user should be involved in the design. That's one of the important principles, right? Even in the grant panels, right? When grant proposals are reviewed, there's consumer there. One of the panelists is consumer. Okay. So if you are designing some fancy arm and he can tell you that I'm not going to use this, right? So he can review that. Okay. Very good. Yeah. Very, very nice answers. So I want to share one experience. There was this Irish soldier. Um, he had he had a leg prosthetic and he also had a hook and he had a badge for one eye. You know this? You know this? Everybody knows this? You know this? Okay. All right. So this guy, so many of you don't know. I saw three hands. So this guy goes to a pub and he's sitting at the pub and the bearer is just having a chat with him. Hey, how are you? And good, and everything is good. And then he asked, what happened? How'd you lose your leg? Okay, and he said, yeah, I was in this war, and we went there, and we were all walking, and I was also walking, and I stepped on a mine ham at last, and I lost my limb, and no worries, I just got a prosthetic, and I'm doing okay, right? And then what happened to your hand? And then he said, yeah, this was during this war. We weren't using any weapons other than swords. We were fighting, and then suddenly I lost my sword, and I did that, and my enemy chopped off my hand, so I got a hook, I got a prosthetic, and then okay. So he understood, right? He understood that you could hurt your legs, you could hurt your limbs, your hands, but I can understand all that. But what happened to your eye? What happened to your eye? One eye, what happened to it? Okay, and he thought that he will hear about one more war, right? So in this war, that happened, this happened. But then this guy said, "No, it was not from any war. One day I was just walking on the road and I looked at the bright lit sky like that, and a bird pooed in my eye. And then with this hook hand, he just tried to wipe it, and then he lost the eye. That's what he said. Okay, so it's a good joke, yeah. But what does that tell you? What's the message? He forgot that he had a hook hand. So what does that tell us, right? It's not just about fitting some prosthetic, right? It's about training somebody to use that prosthetic. Okay. This is the reason. This is the reason, and this is a very, very important. And that's I didn't tell you this joke to waste your time, right? This, this, this is the reason. So we have so many sophisticated prostheses, but there is 80% rejection rate in prostheses even today, right? Yes, 80% of the prostheses are rejected. They get the prosthesis, they use it, they're not happy with it, and they leave it. They abandon this prosthetic. 80%. Can you believe it? And we're all engineers sitting here designing newer and newer limbs, sophisticated limbs, yeah, with touch sensors, that sensors, this sensors, so many degrees of freedom and all this. And there are people that are not using, so like end user, right? If you design something, will they really use it? So this training is an important part, right? And that training is actually done by physiotherapists, right? Prosthetists, physiotherapists. Prosthetists, they will fit the limb. And after that, who is going to take care of this person? Physiotherapists are the one that train this person to how to use this prosthetic, okay? And I know we have two physiotherapists in the audience, And who else? Is anybody else a physiotherapist here? Can you please stand, both of you? The physiotherapists in the audience, can we clap for them, please? Thank you for everything you do. Thank you. Yeah. So these are some of the challenges that we talked about. One is biocompatibility. The other is ease of use, right? They need to learn to use these limbs, right? And then functionality, right? Functionality. So the reaction time we were talking about, right? So how real is this? Huh? So an easy way to disconnect the limb from you is to expand the reaction time. Okay. If you make it slow, you will just lose it. You're like, this is not me. Yeah. Uh, and then cost, right? You don't want to build something that will cost you a space station, right? Um, one time, Akshay Kumar, everybody knows him. Yeah. Akshay Kumar. Yeah, he's my friend. Yeah. So, what movie was he in? Okay, so that group is active now. Okay. Huh? What is that? Robo 2, right? So, the budget of Robo 2 movie, it was more than that. The budget of that movie was same as the budget of Mangalyaan. Somebody went to space and these people are making a movie with that, right? So it is really important for us to make prostheses that could be usable by people, right? So it should be very, very cost effective. That's an important point, okay? All right. So, question back to you again. Okay. Individuals with tetraplegia, okay, or hemiplegia, for example, then neck down paralysis. Okay. So I'm talking about these individuals. So a survey was done. A survey was done to see what are their priorities. What are priorities for them in their life? Okay. And I want you guys to guess these priorities. What could be one of their top priority? And what could be the next one? What could be the next one? Okay. What are their priorities? So if they want something back in their life, right? So that's a priority. So huh? Mobility, that's a very general. I want more specific answer. But that's a good answer. Mobility meaning them going from one place to another. You see, that's that I don't want that general answer. More, huh? Yeah, that is another general answer. I want to be healthy again. Yeah, me too. I want to be slim again. Very good. Independent quality. We'll talk about all those, but I'm being very, very specific here. So, and huh? To a sensation. Some of them have sensation. Most of the cases they retain sensation. Okay. So I already told you the neck down paralysis. Yes. Thanks so much. Okay, so that's the specific. You said mobility, but he's very clear that upper limb mobility. He's saying hand and arm mobility, hand and arm control. To regain hand and arm control was their top priority. Okay, so in the first talk I gave, you guys understood how important are our hands, right? In the activities that we do, you guys understand how much important are those. Okay, so now I'm going to tell you something really, really interesting fact. Okay, so what are these joints called? Everybody still remembers? MCP, right? Metacarpophalangeal joints, MCP joints. If somebody loses their fingers right here, for some reason chopped off, okay, some accident, they lose their fingers right here at these joints, okay, MCP joints, okay. If this person is walking in the corridor, you wouldn't even notice that this person doesn't have fingers. Yes or no? Right? That whole body, what percentage is this? 2-3%, right? In that whole body, right? If this person is walking, you wouldn't even realize that this person doesn't have fingers, right? If such a person lost his dominant hand fingers at MCP joints, this person is considered 50% handicapped by FDA. 50% handicapped. Arm works, wrist works, shoulder works. He has just lost these fingers and thumb. Yeah. he's considered by FDA, I don't know about here, okay? FDA, 50% handicapped. That just tells you how important hand is, right? And also I'll show you the representation of hand in the brain. And you'll also see how important hand is, right? Okay. All right. So survey's done. First priority is hand and arm control. What is the second priority? What could be the second priority? Upper limb ho gaya? Lower limb. No, lower limb control is not a priority. Why? That's the right answer. Wheelchairs are there to take them from one place to another. So lower limb mobility was not a big deal. Okay. Then is the third one. Okay. What is the next priority? Upper limb control, right? That was the first priority. Wheelchair is covering some mobility, right? Okay. What is the next? You may or may not realize this. You may not know this. Okay. And probably it's unfair to ask you such questions. Uh, Bladder control. People with spinal cord injury, especially have this problem where they don't have bladder control. Okay. It's very, very embarrassing. This is again related to quality of life. Bladder control is the next priority. Okay. And the last priority is sexual function. Okay. All right. So these are the surveys done. These are the results. But what I want you guys to notice is that hand and arm control is the topmost priority. You see that, right? Okay. So, all right. Okay. Um, So when we talk about amputations, there are upper limb amputations and lower limb amputations. In upper limb amputations, we have disarticulations, transhumeral and transradial. And in lower limb amputations, we have disarticulations at the joints, and then we have transfemoral and transtibial. Okay, so we're going to see what these are. You don't have to write them down right away. So you'll see what they are. Okay, so in upper limb amputations, disarticulations happen at the joints. Okay, so there's shoulder disarticulation, elbow disarticulation, and wrist disarticulation, right? And then transhumeral is above elbow, and transradial is below elbow, right? So this is for upper limb amputations, okay? And so now we're going to see some upper limb prostheses that are trying to address these problems, okay? So number one is iLimb. Number two is cyber hand. Number three is DECA arm. You already saw the DECA arm in the previous slide. This is, and you'll be seeing a lot of videos, and I'll be asking you a lot of questions after those videos. Okay, so this is one of the prosthetic hands. It's called Michelangelo hand. This is developed by Ottobock, and again, you see the weight. Weight is about 400 grams, right? Yeah. and and the speed is also human-like, okay? And there's a grip force, width of the opening, very, very similar to human hand, okay? Um, and this is powered by a lithium-ion battery, which means it is not so heavyweight. But lithium-ion batteries also have problems that um, when you fully charge them, they will work really, really good for 50%. And then suddenly from 50, they drop to zero. So they're trying to, not my expertise, but they're trying to add some more chemicals, etc., to stabilize this battery. Okay, so lithium ion is good, but it's work in progress. Okay, and then we have this B Bionic. Somebody said this in the first class. B Bionic hand from Orbach. Okay, so we're going to see this video. Wait, is it?
the articulating hand, right? I have multiple patterns that I can control. Those are controlled by my muscles. So it would actually be the muscles that you your wrists that would be sensors that here, right here, inside of my socket. So I'm flexing those muscles, which allows me to move the hand, change the grip, or rotate the wrist, or spin it all the way around if I really want to. That's my fun. I have different wrist options from flexion, legs, I have a speaker, I have 3D printing covers that match my outfit. It's one of those things where, originally all the old hands were the squat collar, which is great. So the people that want to wear that, that's fantastic. I did the options. Over the last couple of years, they started to have one that didn't require the club. And it just looked tempting. And I thought, I've never had a hand. I would have my hand. Why would I? But I can't never have. I think it's cool looking. So I started, not wearing the glove. I then went on to get these awesome 3D printing covers, like that I ordered from Amazon and put in my arm myself so I have a little photo to change my colors. It's things like that where you customize it and you make it more like you. Now, I know we're saying more like you, like obviously it doesn't match my other hand, but it matches my personality. So we'll see the light up rose my hand and end up being both hands. It really takes a whole army to put this together, right? So my hand is made by a company called Autobot, after a really function and rotator. My entire device was built by my amazing Prosthetic and a company called Advanced Dynamics. I have these really cool like cell lithium-ion batteries. They're as thin as a credit card, and for someone who has a short residual lift, that extra lightness on it to give it weight, it's been amazing. The company that created my really cool 3D printed cover is called L07 in Canada, and they do some amazing inclusive design for the implementation. I'm preparing my own device since I was very young, so I've been through the progression.
Oh, sorry.
One that didn't work the way I wanted it to. We're still not exactly there, right? There's still room to grow. There's still so much happening in the future. But this device allows me much more independence. But then it takes much less time, and nobody else is finding help. That's like a really cool benefit of it. And this is where there are so many things coming out that have me so excited about the things that could be modular and animal, and things that are also fashion and things that are more functional. The ways to control the devices is going to be great for people who have less limbs than I do. The ways to wear it that are also attached on structurally. And it's just a really exciting time to be a person with disability because we get to have all this stuff for everyone else. So it's really cool. It's the first time they actually have brain compatible belts, which means that I can actually use my phone with my hand now. Also, I have this really cool belt that's positionable from opposed to unopposed. And these links that are designed to break if I put too much pressure on it. It's great because before when they broke, it was a motor issue, and I can have my hand for like weeks. And then the really cool cover, you can see all the way through it and into it. I can actually do my, modular stuff where I can take off my hand as well as switch out the covers so you can see inside in it and see the lights, you can see the charger, you can see all the things that are internal. It's really easy in the morning to just get dressed, right? Slide on the cover I want, turn on the lights, pop on my hand, right? And I'm just ready to go. How much it's been amazing so far. There's been so many people that have been really interested in talking about disability and inclusion and technology. So I've had a lot of fun. Thanks so much.
Okay. So that video was what, 3 minutes? She shared about 30 things in that video. Okay, so that are related to prosthesis, function, quality of life, etc. Okay, so I want to hear from you guys. What did you hear from that video? What are some of the things that hit you? The hand moves in. that was really cool, right? Yeah, yeah, very good. Yes, yeah. So that was one caught attention, right? Right. It was like, and we cannot even do it, huh? Right, right, right. Very good. Okay, so that's one that looks superhuman, right? Superhuman function, yes. Okay, what else? Very good, Very, very good answer. Yes. So ease of use, right? You saw she made a comment that so it's really easy for me to put it on, take it off, right? On and off, very easy. Yes. What else? Huh? Very good. Yes. Aesthetics in prosthetics. It's really, really important. It's coming there. I have one more video about it. Yeah. Aesthetics in prosthetics. She made it look really cool, right? Right. So she talked a lot about her new limb not looking like her real limb, right? It builds confidence, right? Right. Very good. Very good answers. Yeah. Okay. And she also talked about female design in there, right? She wanted to match her personality. She used that word, right? Okay. Anything else? The lights, right? So that's very good point, right? So um, she could buy these things on Amazon and she could integrate them, right? And what else? What else she bought on Amazon for that limb? Huh? She bought something else from Amazon for that limb. What was that? Huh? Covers, right? So she bought covers on Amazon to put it on top, right? So just like you get cell phone, but you cell phone covers you buy on Amazon to put it on top. You see that, right? So yeah, stop. Huh? Oh, short break. Short break. Okay, okay, okay. We'll finish this. We'll finish this and have a break. Yeah. Okay. Keeping time. And when did we start? 30 minutes. That not a month. What time did we start? Huh? 10:40. So it's been 40 minutes. Okay. We'll finish this and then we'll take a break. Okay. Okay. So 3D printed covers. 3D printed covers that you could buy from Amazon, the lights, right? Aesthetics. What else? Very good. Yeah. So she had these fingertip not sensors, but um, yeah, sensing material. So she could use her phone with the prosthesis. These are wants to use a device in the daily life. Yeah. Very good. Okay. What else? On and off, flexibility, ease of use. Yeah. Yeah. But good answer. Yeah. Right, right, right. Very, very good answer. So it's not like, okay, so you put the prosthetic, okay, put your one electrode here, second electrode here, third. She didn't do that, right? Yeah, very good. Yes, yeah, yeah. And how was she controlling the prosthetic? What signals was she using? Muscles. Yes. Okay, so it's like the expert movies. Very fun here. Okay. All right. And then there was one more thing that she said. This was directly related to the device design and performance. What was that? Right, right. Very good answer. Very good answer. So these joints, they if they break or if they have some problem, they come out and she can put on a new thing, right? That way they are not hurting the motors. Okay. When we were using modular prosthetic limb, the video that you saw in the lecture one, when we were using that in brain control, sometimes the motors used to overheat and the fingers used to fall off. We used to call it digital lepers. Okay, so fingers used to fall off. They were overheated and the fingers used to fall off. But if you have a modular design like this, you add one more, right? So they are not hurting the motors, right? But again, this design it only has 5 degrees of freedom, so it is controlling the um, all the joints from 5 motors from here. Okay, so it's not like it is hurting every joint. Okay, all right. There was one more thing. There was one more thing, one last thing in the design. I'm sure maybe you've noted more, but huh? Light? Somebody said light? Oh, lightweight. Yes, that of course, yes. Lightweight, yeah, that is important as well. Lightweight, I think some of you mentioned. So there were also lights, right? Lights you could get from Amazon. And there was also sound. There was sound from the device. Okay. You could also use that, right? But then on top of all this, she said something else. And I think one of you touched on that is um, earlier designs, there was a glove that she could slip it on that hand. So that glove would be skin color, right? And it would make it look like a close to a real hand, right? That's how it was, right? But now she said she took it off. She didn't want to. Why even think about a hand that I don't even have, right? Remember that, right? So that design element is also really, really important, right? So cell phone, right? Cell phone, we are addicted to cell phone. We love our cell phones, right? Right? I have two of them, right? Yeah. So why do we do that? We're so attached to it. They don't look like any of our body part, but we're so attached to it, right? Can we do that for a prosthetic? That's what Autobot did, right? That the user got really attached to it, right? Okay. I'm going to share something cool, but after the break. Okay. Enjoy the break. Thank you.